Today we are going to see a very important topic, that is about data centers. What are data centers basically? So these data centers are playing very vital role in storage of data, which are having a lot of information related to healthcare, as well as the marketing, sales, and those kind of data, and judicial kind of data. So many data are present. So how these data are being actually stored? So we day by day the generation, actually the peoples are growing, lot of information related to the people, lot of information of safety related aspects of the people and health conditions I told, and disputes related, those kind of things is very important to maintain nowadays. Everything it is stored in a very just we store our data on a pen drive kind of thing or a hard disk. So here you can see the data is basically stored in a data center. It's a place where all the data is being stored, what I can say. So how this data center has to be maintained? So lot of data, if you take a laptop, your own laptop guys, it is going to generate lot of heat. A small kind of laptop, 2 GB, up to some other GBs, higher GBs and all, it is starting, it will try to generate a lot of heat based on your operation. So these kind of servers, if you are want to protect this data, there should be a lot of cooling in this kind of storage areas, and this equipment and hardware related to the data centers has to be protected very perfectly, which don't also require more moisture, and the moisture also need to be controlled. These are the various things we need to take care in the data center. So now the lot of jobs also are going to be generated from data centers, because all the data related to uh, everybody, healthcare or other things, sophisticated informations, everything has to be designed, everything is needed to be stored in a data, so which has to be also preserved very perfectly. So this is the topic, today's topic, and I think you are going to enjoy it guys. Let me go through the topic. So you can see these are the data center servers. The black one is 1 2 3 4, the black one is data servers, and you can see there is a raised floor that is called, so blue color one, that is called a tiles and raised floor. So you can see here the blue color air is coming from the floor grill to the servers, and it is taking away the heat, and the red color heat is again it is going back to the unit already which is installed. That this is called hot acid, this is called cold acid. So there how the heat is removed, so this may be removed in two process, through cooling towers, or maybe the DX system, that is cooling of condenser in through passage of air. So these data centers maintenance and scalability and designing also plays vital role here. So we also need to understand how we need to design and what are the parameters and factors we need to consider for designing a data center. So now we are going to deep into these things. So the data center is actually having some types of units. These units are called CRAC units, CRACs. So the CRAs are called computer room air conditionings, and this is a device that monitors and maintains the temperature distribution in a data center. So the CRAC units also replace the normal air conditioning used, because they are not that much sophisticated. Actually, because the CRAC has better filtration as well as the humidity and moisture controlling, as well as moisture application requirement. Also it will supply depends upon the lowering of moisture. This is the way it can be controlled. Here also the CRS ACs will be helping the to prevent the low humidity, as well as the water vapor. If it is more, also it is also trying to control. Okay, because if there is a more water vapor, the what do you say, this electronic component which are going playing vital role in storing the data, it may get short circuited. So this is the way we need to have a precision control over temperature, as well as the precision control over humidity is also very important required in the this data center. cooling applications. See, now we'll come to the CRAC units and including the components. So basically you guys know this is the refrigerant, actually refrigerant and cooling coils, as well as the compressors and air filters, as well as EC fans. Okay, so EC fans also is electrically commutated fans and all. These also works on AC and DC, as well as you can see humidifiers and dehumidifiers are there. Humidification is for supplying the humidity, as well as dehumidification is for removing the humidity. So coming to the CRAH units, these are called computer room air handler. These units also is called another type of units. The major difference between CRAH and CRAC is how they cool the surroundings. This is only basically depends on. So you can see here in a CRAC units you can find the refrigerant and compressors, but in a CRAH it's used chilled water as well as the control valves. This is the main difference, guys, in this both of these things. So actually in CRAH units the fan blows air over the coil instead of the coils. Actually the refrigerant will be filled actually. So you know that when the refrigerant and compression is happening, so it will try to capture the heat which is present in the copper coil and it return back to the chiller. So it is removed from the cooling tower as well as those kind of things. And if you come to CRH units here, they don't need any compressor here, because it works on another kind of method, and it is basically used for data centers. See, generally the CRS units is ideal for data centers with electrical loads up to 20 kilowatts. This is the main difference you can find here. When you come to CRAH, it works for the electrical loads more than 20 kilowatts. So how this system is working? Based on the chiller DX system as well as cooling towers are air cooled. Suppose if you take a chillers of DX systems, in a chillers the water will be circulated inside the chiller, that is the evaporator, and the heat is dissipated back to the cooling towers. In an air cooled system you can see the evaporator is same, the cooling coil is same, but the heat removal process here is based on flow of air. So air suction will be there, from there it is trying to take out the air. Air distribution strategy, you can see the air distribution strategies also need to be individually circulated, because air distribution in this one is very important, because more air has to flow on the heated component as well as that needs to be dissipated back to the unit so that it can start removing the heat from the air. Backup systems, here the redundancy is very critical, because data center, if you see, there should not be any stoppage of cooling. In any case, its breakdown is going to be causing very important threat, because it should have a proper generator or secondary system to prevent the failures and catastrophic data losses. So coming to temperature and humidity controls, you can see the temperature between 20 to 25 degrees Celsius to prevent overheating, and as well as the humidity can be around 40 to 60% and 50% you can use to avoid the electrostatic discharge. So guys, I am telling you, you have to remember these 2 points, very important, because somebody may ask what is the temperature control inside a data centers, and you need to have a remembrance of these things. So most challenges actually what the data centers being encountered. So coming to this, when designing the data centers, it is very important to take the heat load estimation related to operation servers, as well as what is the amount of heat dissipated by server, and what is the kilowatt that is generating, and per kilowatt how much heat is going to be generated. It's very important in taking from the vendor before designing the things. That is also very important. And coming to the density racks, as the density of racks increases, the servers also increases, and the concentration of heat also will be increases. So seasonal variation also you need to consider fluctuations. So what are the fluctuations? Maybe high moisture and very high heats in a seasonal changes and seasonal shifts. It's also very challenging in data centers. which you need to understand. Coming to energy efficiency, we need to have an data centers because it's a notorious energy hogs, you can say, because these are the guys which are continuously running 24/7. We should have some of the efficiency methods in trying to cut the bill. So we'll see further this thing, what are the things we need to do here. So we can incorporate the variable speed drive so that the power usage based on the temperature achievement, so that the chiller can trip down or the fan can start switching off, throw off air once the temperature is perfectly reached. The maintenance on downtime, the cost of downtime in data center can runs up to more than millions per hour, because making a schedule is a heck, and it's risky, as well as a continual operation also is very required, and it's also very important. Coming to the predictive maintenance of the data centers, you can have a predictive analysis with an proactive approach, so that what are the things we need to take care before the stop of an data center instrumentation HVAC systems which are related. We can take a note of that also. Redundancy planning, the maintenance of redundancy of HVAC systems. So this is kind of another topic related to backup, and you can have and look over these things also. This mainly while considering the HVAC design for data centers, we need to size the capacity planning and scalability. Scalability, we can suppose some more equipment is going to come, so whether we are able to increase the equipment within that space, that is called scalability. So we should have a pre-planning on these things before taking consideration or designing, because I mean to say that we should have a design temperature, the TR should be higher rate, little bit some kind of percentage backup we need to take before designing. The right sizing is also very important, because oversizing also will lose the loss of feeding energies, power losses, and a lot of unnecessary breakdowns may happen because of overloading of that kind of things. So these are also very important. So I said the redundancy backup systems. This is, we should have a backup system. So redundancy backup and airflow management is very important. I also showed you what is hot and cold acids. So best practices you can see here. The regular inspections of preventive maintenance. Regular inspection is required in case of data centers. And another one, inspections of frequency visiting, and what is the component regularly failing also has to be noted down. And preventive maintenance schedules, I already told you, monitoring and optimizations. We need to regularly monitor the temperatures of inside conditions, whether the optimum temperature is being achieved, or whether the load generated by the server is also affecting the HVAC systems. This is the time we need to take. This can be done with only the one process, that is called automation. By automation, or by doing the automation of system, we can have total control of the system, whether how much data is populated, and with the temperature and the load estimations, whether it is achieving the perfect values, or whether this old system, sometimes the data center becomes old, they start giving more heat also. This may be the another reason we need to have an automation, so that we can have a real-time data in our hand. We can interlock with an AI, machine learning and optimization things also too, which are placing nowadays a very big role in HVAC systems. So just like the predictive analysis and adaptive analysis, so you can have a look over the chilled water system, how it looks. This is a cooling tower, this is a CRAH unit. So heat is absorbed and the water is circulating. This is a pump where water will be circulated, used to a pump to circulate water. In this pump is circulating water between evaporator, this is circulating between the condenser. So it is taking the heat inside the data center, and it is throwing out through the chilled water systems. This is one system. Another thing you can see, air cooled system. See, in air cooled system, the cooling tower is replaced with the condenser. Here only the air through fans is removed from the coil. So water is flowing here over the cooling tower, over the coil. So but here you can see the heat is passed from the down, and it is removing the heat. Okay. So here you may be asking a question, sir, how this is circulating? This is through compressor. The compressor is circulating the refrigerant between suction and discharge. And you can see here, this is a CRAC unit of a computer air conditioner. So you can see top the filter is there, the return air is going from this area and it is filtering and falling over the coil and getting cool, and it is again throwing to the other side. So this is the cooling coil filter. Before air is entering the coil, it is getting filtered. So in order to prevent the damage to the coil, and humidifiers are there, dehumidifiers are there, whatever the temperature is achieved, based on this thing, these two guys are going to control the moisture, and this is a fan which is going to throw the air after meeting all these things, all the temperature parameter, humidity and dehumidifier. I know guys, you understand how these things are going to manage, because they have different sensors, and with the sensor you are going to these guys are going to manage, and the air is thrown accordingly. If you see from the top view, the AC arrangement will be like this. These are the indoor units, and indoor units all are connected to outdoor units, and this is the arrangement of racks I told, and this boxes is called floors. White boxes are called floors. From the down of the floor, air is flowing like this, and hot air is going like this. It is taking the heat and becomes hot air, the cold air becomes hot air, and it is going to the unit again back. This heat is thrown away from the outdoor unit connected to these units. Okay, so try to have these things understanding. So you can see here, from the floor it is passing through the rack, and from the rack it is taking the heat from this area and throwing and getting back to the units, and again it is cooled and coming back. But this heat is taken outside the building. This is also one of the image, you can have a look. See, this is sometime one of the formula you can say. Suppose CRAC units is equal to number of IT cabins into kilowatt per cabin. Suppose for example, if you have 90 kilowatt of CRAC cools 90 cabinets, the average cooling delivered per the cabinet is 1 kilowatt, because 90 kilowatt is equal to 90 into 1 kilowatt cabin. That's what they have said here. Suppose if you are having 90 kilowatt CRAC cooling cabinets, then average cooling delivered per cabinet will be 45. So because 90 is equal to 2 into cabinets into 45 kilowatt by the cabinets. So this is a small formula kind of things. Okay, depending on that you can take per cabinet how much heat is generated and multiply, you can get the kilowatt. So from this kilowatt you can try to size the equipment. And experience in the designing, operation of mechanical systems, top roof units, CRAC, HVAC, exhaust fans and other air quality comfort. These terminology and these are the points they are going to be asked in interview. So you try to have a deep discussion or having in a Google verification, try to do this and understanding the temperature, air, so based reports and all. Okay, testing air balancing, this is called TAB. So these also recommend settings and all you have to understand. So finally coming to these things, you have to understand about the codes. So sometimes you have to understand about the building IBC codes as well as National Electric Code as well as AMC, NFPA and ASHRAE. Try to remember guys, these codes they are going to, if you want to go abroad for any kind of interview or jobs, so you have to have a good knowledge on the these type of standards also. That's why I'm trying to call you and recalling all the things. Okay, this is the unit it looks like. So top is opening, it will air is coming inside and it will go like this after cooling. Okay, this is an indoor unit. So you can see here Liebert Deluxe Systems. Liebert is a company who are manufacturing some interviews. You may ask question, what is your make? So you can have a data because it will be useful. So you can say that this is the Liebert Deluxe Systems. 6 ton, 8 ton, 10 ton, 15 ton up to 30 ton. You can select based on these things. So how much is sensible load it is going to take and remove, maybe what type of unit you need, air cooled unit, water cooled glycol, or only glycol. Okay, so you can see here this is an air cooled system. You can say here chilled water system. You can go for air cooled system, or you can go for chilled water system. These are the model numbers DH, VH and 114A. These are the units. Okay, you try to have understanding FHU and UH 200. So these are the units. Okay, this is water flowing system. This is air cooled system. So finally, you can see what are the factors affecting data centers. Guys, this is very important. Main factor affecting in the data centers is a lot of corrosive gas which are present outside the data center may directly react with the very costly electronic components of data center inside, and also prolonged humidity and toxic and corrosive gas natures, sewages, drains, high density traffics, and all these are the things which are going to affect directly the components in the name of corrosion. That is one thing. And the contaminant gases and humidity air also seeps into the data processing facilities and start eroding the economic electronic components and all. So it will be losing to the it will be a final result for the PCB failures and all. So sometimes you need the dehumidifiers to use it in the server rooms also to remove excess moisture to a desired level, otherwise it is going to affect again. So silver corrosion, sometimes the silver sulfide corrosion films also can be causing on the insulating layers. These may cause electrical failures as well. And creep corrosion, another thing, the phenomena is that occurs in electronic industries, electronics as well, and these are driven by the corrosive elements such as moisture, sulfur compounds and all, which may penetrate and start eroding the components. So with this, I think guys, you had an good understanding on the data centers, and you try to have an updated knowledge in data centers. So for freshers, experienced people, you can understand the outline of the data centers HVAC systems. So with this, thank you so much, and we will try to attend one more topic in coming days. Thank you.